Hi everyone, welcome back. Today we're doing minimum window substring. For this question, we're given two strings s and t of length m and n respectively, and we have to return the minimum window substring of s such that every character in t, including duplicates, is included in the window. And if there is no such substring, then we return the empty string. So in this case, the test cases will be generated such that the answer is unique. And a substring is a contiguous sequence of characters within the string. So for the first test case, we have Adobe Code Bunk, and the T, the string that contains all characters that we need in the minimum window substring, is here, A, B, C. So in this case, the minimum window substring is B, A, and C over here. For the second example, S and T are identical, so the minimum window substring is S itself. And for the final example, T is a string that has more characters than S, so there are no possible minimum window substrings that contain enough characters in T, so we return an empty string. So for this question, M represents the length of S, N represents the length of T, and both M and N range from 1 to 10 to the power of 5 characters. And S and T consists of uppercase and lowercase English letters. In this case, we will take uppercase and lowercase characters as two separate characters. So to solve this question, we can use a sliding window approach. And to be specific, we'll be using a sliding window to check whether to get a potential candidate minimum window substring, and to qualify that as a candidate, we can check whether if all characters inside that window is sufficient, contains the characters in T. And we'll be keeping track of all characters and their frequencies in T using a dictionary. And we will also use a second dictionary to keep track of all characters along with the counts in the sliding window. We can make some additional optimizations to speed up that search, but we'll be going through that in a bit. So the idea is, if we have a sliding window starting off from the left side of S, and we try to expand the window outwards from left to right using the right pointer, we will continue to do that until we have sufficient characters to make up all characters in T. And once that is achieved, we can try to minimize the substring by moving our left pointer towards the right, popping out characters within the substring until we get a minimum window substring. So that's pretty much the approach we're going to have for this question. So let's quickly get started. So the first step will be to populate all characters in T into a dictionary to keep track of the counts, and this will speed up the checks. So we will do T dictionary. This T dictionary will contain string keys. Each of these keys represent a character in T, and we have an integer as well, and this will be the frequency of that character in T. We will do an iteration in T to populate this T dictionary with their characters and frequencies. So for character in T, tdict char is equals to tdict.get char 0 plus 1. So we will get the existing count for that character and we increment it by 1. And that's pretty much it for the first check. The second thing that we're going to do is to define a left and a right. This left and right index will represent the indexes of the current sliding window, and we will set this to 0 and 0. So we set this to 0 and 0, and we'll be using the right index to expand outwards from there. So actually, we can just define L equals to 0, and we will use a for loop instead to represent the right index. The next thing that we will have is also a window dict. And this window dictionary will keep track of all characters inside the sliding window. And over here, the next thing that we will define is also, let's also define the answer left. Let's set this to an optional of an integer, and this will represent the index of the left index of the window, if it is a valid minimum window substring, this will be set to none. And we have an answer right. Let's set this to none as well. And we will also have an answer length. And we'll be using this answer length to represent the current length of this answer. And we will set this to a very high number. This corresponds to the maximum size of m and n. So this will be overwritten once we find a minimum substring window. And that's pretty much, there's also a few other things that we can do, I guess. We can also keep track of number of characters. Actually, let's call these unique characters in window. And we'll be setting this to 0. And we also define unique characters in T. These unique characters in T will be set to the length of T dictionary. And so let's say your T consists of, let's say, ABC, then we'll be having 3 unique characters in T. Every time when we iterate through the whole of S to check if we have enough characters, we will see whether if the current character we're looking at using our right index is one of the characters in T. And if it happens that we just achieve enough characters to match the number of characters in T, then we will be incrementing this variable over here. And to determine whether if a window is valid or not, we'll be comparing unique characters in T with unique characters in T. So if these two variables are the same, then we will take it that this current window is valid. And of course, as we try to shrink the minimum window substring, if the character that we are trying to pop off from the sliding window happens to be one of the characters in T, and after popping off, we now do not have sufficient characters for that, then we will also use this. We will also decrement this variable over here so that we no longer have a valid window. So that was a lot of words, but we will see how this is used in a bit. So now we will do for R in range of length S. We are using the R index over here to expand from left to right. And what we do at each step is to get the R character. This will be S at R. And we will be incrementing the count of this character inside the window dictionary. So rchar will be equals to window stick. One optimization that we can do is check whether if rchar is in T dictionary. So if the rchar is in dictionary, then we will increment this inside the window dictionary. This way, the window dictionary only contains characters that we really need to keep track of. And to be specific, we only keep track of characters that appears inside T. So window dictionary over here for rchar will be equals to window dictionary.get rchar 0 plus 1. So we are pretty much incrementing the count of this rchar inside the window dictionary. One additional thing that we will check is, by any chance, after incrementing the count for this character, do we now have enough characters to fit in T? So in other words, if window dic get rchar, or rather rchar, is equals to tdic rchar, then we will increment the unique characters in window by 1. And that's pretty much it over here. So one thing that we will also do is, while unique characters in window is equals to unique characters in T, in other words, if the current window is valid from left to right, then we will try to pop out characters on the left side and also update our left and right answer over here. So we first update it, and afterwards we try to shrink the window while trying to keep the window valid. In other words, contain all characters in T. So the first step would be to get the length. So let's get the window length. The window length will be equals to r minus L plus 1. And the next thing is to check if the current window length is less than answer length. And so if the current window is smaller than the current answer that we have, then we will update answer left with L, and we'll update answer right with R, and we will update the answer length to the current window length as well. So we pretty much update and take the current window as the minimum sliding window we have. It happens to be shorter. Now the next step will be to try to sequentially shrink the size of the window. So we will first get the current count. So we will check whether if the current, let's quickly get the left char over here. This will be equals to s at L. And we will check whether if L char is in T dictionary. So if this character is important, in other words, this is in T dictionary, then we will check if the current window dictionary for left char is equals to T dictionary of L char. So if this is the case, it means that if we remove this left char, then the window will no longer be valid. So if that's the case, then what we will do is we will take unique characters in window and subtract it by 1. In other words, we no longer have enough of that unique characters in window. And the next step would be to take L, would be to decrement this count in window dic. So window dic L char minus equals 1. So at this point, we have successfully shrunk this. And if this happens to be a crucial character that we popped to make this window no longer valid, then this while loop will terminate. And subsequently, we will try to move the right index towards the right in a bit to find the same character that we just popped. So that's pretty much it. So at this point, we can do, if answer left and answer right is not none, then we will do a string slice of S from answer left to answer right plus 1. So we will return S from answer left to answer right plus 1 if answer left is not none, else empty string. So that's pretty much the answer over here. So let's quickly run this through with a test case. So T dictionary will be, let's define T dictionary to be an empty dictionary here. And let's have the character represent the first character A. So we will put A into the dictionary. On the second iteration, we will set this to B. And we are finally at the final character in T, that is C. So we will populate C inside here, and we are done with the iteration from 12 to 13. Now the left index will be equals to 0. Our window dictionary over here will be empty. Answer left will be none. Answer right will be none. And answer length, the current length of the minimum window will be 10 to the power of 5. Unique characters will be 0. Unique characters in T will be the length of T dictionary. In this case is 3 because we have 3 keys. And we can start iterating our R from left to right. So our char at index 0 would be A. I will copy this and paste it here so that it's easier for tracing. And in this case, our char is indeed in T dictionary. So let me also copy this and paste it here just for tracing as well. So now, since our char is in dictionary, we will put this R char inside our window dictionary. So window dictionary would have this character over here. And in this case, because the count of A is indeed equals to the count in T right now, we will increment unique chars in window by 1. And this is not true because currently our unique chars in window is 1. And this is not equals to unique chars in T, which is 3. So this is not true. so we will skip this. So we will now go to index 1. Our sliding window has a length of size 2 now. Our char is now equals to D over here. And our char is not in dictionary, so we skip this stuff. We will continue. O doesn't exist in dictionary, so we skip that. Let's go to R equals to 3. Now we have B. B is not in dictionary, so we skip it. 4. E is not in dictionary, so we skip it. Actually, did I just miss? Yeah, I just missed this, did I? 0, 1, 2, 3. Yeah, R equals to 3. And R is equals to 3, our char is equals to B. So B is in T dictionary, so our window dictionary will be populated with that as well. So we will increment it here, and unique char's window will now be equals to 2 because our B's and our B's here are sufficient in both dictionaries. So let's move on. R is equals to 4. What's the character after B? Is E. Okay, E. Okay, E is not in the dictionary, so we will skip this. We are at character 5 now, so C, and now we encounter C. So in this case, C exists in T, so we will put C in the window dictionary here as well. So at this point, we increment unique characters in window, and now both of these variables are equal to each other right now. So because this is true, we now have a valid window. We can try to shrink the window over here. So the window length over here would be 5 minus 0. So this gives us 6. 5 minus 0 plus 1 equals to 6. And window length in this case is 6 less than 10 to the power of 5. So we will update answer length with 6. Answer left and answer right would be set to the current R, so this is 5, and left would be set to 0. So answer length would also be equals to window length. So window length in this case is 6, so we update it here. And now we will try to shrink the sliding window. L char is now equals to S at L. So L in this case is index 0, so that is A. And because L char is in dictionary, this is true. And the current count in the dictionary is equals to the one in dictionary. So because we are trying to remove this character, we will now decrement this by 1. We will decrement unique characters in window by 1, giving us 2. And we will decrement the window dictionary for this L char by 1. So this will be set to 0. And now we no longer have a valid window, so we will try to compensate by expanding towards the right until we get back A. So now we continue. R is equals to 6. Previously we were at C. Now our char will be pointing at O. So our char is not in T dictionary, so we skip this. R is now equals to 7. So now our char is equals to, what's the previous one? Is O. So now this D. D is not in T dictionary, so we skip that as well. R, let's move it to the right again. Now we get E. In this case, E is not in T dictionary too, so we skip that as well. Let's go to R equals to 9. Then we get B. And in this case, B is in T dictionary, so we increment window dictionary by 1, giving us 2 B's. And nothing remains changed because the count in window dictionary is 2 equals to 1. So this is not true, so we don't update this. Let's further shift the R index to 10. So now at 10, we get A. And this is the character that we are looking for. So over here, this would be true. We will increment A by 1. And now, because the window dictionary for A is now indeed equals to T dictionary, we will increment unique characters in window by 1. So now we get a valid window again. So we will execute line 43. This is indeed equals to 3. 3 is equals to 3. Window length will be equals to 10 minus... Okay, let's see. Where was L? Oh, yes. I didn't update L previously, did I? Yeah, I didn't update L previously, but L is now equals to 1. So let's see. Our current R is 10. Our current left is 1. 1 plus 1, that gives us a length of 10. Now 10 is not less than 6. So we don't update our current window with this stuff over here. And now we are trying to shrink the sliding window further in a bit to get the minimum window substring. So L char will be the character at index 1 because L is 1. So this is D over here. So L char is equals to D. But because D is not in T dictionary, we skip all this step. We continue. Let's see. Did we miss out a step over here? Yes, we did actually. We were supposed to increment L by 1 after we get the left character. So thank goodness we traced this. We noticed this error over here. So now D is not in T dictionary, so we skip all of this stuff. Now let's increment L by 1. So that gives us 2. And now we continue. So now we have D. Yeah, I need to remember that the string is over here. Okay, so D is not in T dictionary, so we skip it. Now we have O. And over here, our window length is 10 minus 2. L is equals to 2. Actually, let me just copy this and put this below so that it's easier for us to trace L. So let's just put L here. So L is now equals to 2. The character at 2 is O, okay. And we increment L by 1 again, giving us 3. And similar in this case, O doesn't exist, so we skip this. Now let's access 10 minus 3. This is equals to 8. 8 is not less than 6, so we skip the updates here. Let's go to B for index 3 over here. So B in this case exists in T dictionary, so this is true. And the window dictionary for B is B equals to, is our count in B right now equals to, no it's not. So we will decrement this and we will continue. So right now, let's see. Now we have index equals to 3, 0, 1, 2, 3. We have just dealt with B. Now L is equals to 4. Now this will be 10 minus 4 equals to 7. 10 minus 4, 6 plus 1, 7, correct. So 7 is not less than 6. So we don't update our current windows. Left character is now equals to, let's see, E. E is, sorry, we will increment L by 1. So this gives us 5. And E is not in T dictionary, so we skip line 53 onwards. Now we are back here again. So now this is equals to 5. 5 minus this gives us 6. 6 is still not less than 6, so we skip line 47 to line 50. Left character is now the character at index 5. So C. C is indeed in T dictionary. So in this case, let's check the counts for C. So C and C over here, they are the same. So we will decrement unique characters in Windows by 1, giving us 2. And we will decrement the count in window dictionary by 1, giving us C equals to 0. And now line 45 is no longer true, so we break this loop over here. Now we are back to trying to expand the right pointer of the sliding window until we find a C again. So now we set R to be equals to 11. So index 11. So for index 11, this is N. N is not in dictionary, so we skip this and we continue. And now we're at the final index, R equals to 12, and this is equals to C. So R character is indeed in T dictionary, so we increment C by 1 again on this line over here. And because the two counts of C are equal to each other, we increment unique characters in window again, giving us 3 equals to 3. And this allows us to execute the while loop again. So the window length now is 12 minus current L, which is 5. So 12 minus 5 gives us 7 plus 1, 8. So 8 is still not less than 6, so this won't be executed. Now the left character is the character at index 5. 0, 1, 2, 3, 4, 5, which is C. Actually, we went through C already, did we? So L should be equals to 6. So L over here should be O. So we will increment L by 1 again. So let's set L to 7. And because O is not in T dictionary, we will skip all these steps and continue on line 45. So window length will now be 12 minus 7. So that gives us 6 actually. Yeah, I made some mistakes over here, but you get the idea in the tracing. So left 6 is not less than 6, so this is not true. Left character will now be the character at index 7. 0, 1, 2, 3, 4, 5, 6, 7. The character D right after O. So this is D. L will increment it again, giving us 8. And L character is not in dictionary, so we skip this. And let's go back to line 45. So now we have 12 minus 8 plus 1. So that gives us 4 plus 1, 5. Now 5 is indeed less than 6. This current window has a length of 5 and is shorter than the current minimum window substring. So we will update answer length. So answer length will now be equals to 8. So answer length, answer length in this case will be, answer left will be equals to 8, right will be equals to 12, and answer length will be equals to 5. So we are done over here. We have updated our current minimum sliding window. And let's set L char to be equals to L right now. So at index 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Which is E over here. So we will increment L. Now this is 9. And since E is not in T dictionary, we will skip this step. And now we are back at line 45. So current window is 12 minus 9. That gives us 3 plus 1, 4. Now this is an even shorter sliding window. So we will set answer length to be equals to 9. And right stays the same because it's still 12, and the answer length will be equals to 4. Now we are at line 51. The character at index 9 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is B. So bunk. And we will increment L again. Now this is equals to 10. And since B is in T dictionary, we will check this. The current count of B in the window is the same as the T dictionary right before subtraction. So now we will decrement unique characters in window. Now this is 2. And we will also subtract the count of B in window dictionary, setting this to 0. Now this is no longer true, so we terminate for this R and O because R is 12, the final index in S. So we terminate the search and we pretty much got the answer. So in this case, this would give back the answer S from answer left 9 to 12, and in 12 plus 1. So index 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to 12 giving us bunk. And this gives us bunk, which is the same answer for the first test case. So it looks like our current approach works fine. Let's try writing this out again. So let's remove all of this stuff. We already got the implementation already. We just have to re-implement it again. So let's try this. Okay, so the first step will be to iterate through all characters in T and put it into a T dictionary. So like what we see over here. So T dictionary equals to empty dictionary, and we iterate through all characters in T. T dictionary for characters equals to T dictionary get char 0. In other words, plus 1 to all current counts that it has. The next step would be to define the left index and also define a couple of helper methods, a couple of helper variables. So let's define the window dictionary. This will keep track of all characters inside the window, and we will also define answer left. This will be set to optional for now, as well as the answer right. The answer length will be set to a high number, 10 to the power of 5, which corresponds with the longest length of S. And the next thing would be to define unique keys in window. This represents the number of unique keys which we have enough counts of in the window, and also T unique keys in window. This would be the length of T dictionaries, so the number of unique characters that we have in T. And once we're done, we can start iterating left to right and trying to expand the sliding window towards the right. So we will set this to R for R in range of length S. And the first step will be to get the character S at R. And we will check whether if our char is in T dictionary. And if our char is in T dictionary, then we will bother updating our window dictionary with this count. So our char equals to window dictionary.get our char 0 plus 1. And now we will check if window dictionary our char is equals to T dictionary our char. Then we will officially say, okay, we have one new unique key that we have enough counts of. And that's pretty much it for this step. The next step is to check whether if like our window, while window dictionary, actually it's just unique keys in window equals to T unique keys in window. In other words, if the current sliding window already has all characters in T, then we will try to update our current answer with the minimum sliding window and try to systematically move our right pointer towards the right. So now we will do window length equals to right minus left plus 1. And if window length is less than answer length, then we will update our current answer with this valid sliding window that we have. So answer left equals to L, answer right equals to R, answer length will be equals to window length. And now that we have updated the answer, we will try to pop the character on the left. So the left char in this case will be S at L, and we will check if L char is in T window. If L char is in T window, T dictionary, then we risk making this current window invalid as we move from left to right. So if let's see, if window dictionary L char is equals to T dictionary L char before the deletion, then before the deletion from the sliding window, then we will set unique keys in window, subtract it by 1, and we will do the same thing of decrementing the current count for this L char. So that's pretty much it for the shrinking logic, and we will return S from answer left to answer right if answer left is not none, else empty string. If answer left is none, then it means that we have not found a valid minimum sliding window. This will only be updated if we happen to have a valid sliding window over here. So this looks fine. Looks like everything is okay. Let's remove this stuff that we have, and let's quickly do a final check. So over here, we update the T dictionaries. We use key T dictionaries to keep track of all characters in T for easier checking of whether if a window is valid or not. We define our left pointer for the window over here. We define a window dictionary to keep track of all characters and their occurrences. And this window dictionary only stores characters that corresponds to characters in T dictionary. So we only keep track of characters that we need to. Answer left and answer right is the final answer. We define it to none so that we can return an empty string. We will just check whether if answer left is none to determine whether if there is no minimum sliding window. This answer length is set to a very high number so that this can be easily overwritten if we find a minimum window substring. And unique keys in windows will be used for us to check if the current window is currently valid. And we will increment this whenever our current window has enough characters corresponding to the T over here. So we get the character on the right side of our sliding window, and if this right character corresponds to any character in T, we will increment it in the window dictionary. And if this current character happens to have the same count as T, in other words, it means that we have enough characters for this current character, then we will increment unique keys in windows. If these two variables are equals to each other, it means that we have a valid window. We will get the current window length for this valid window. We check it with our answer. If it is shorter than our current answer, we update it. And once done, we try to shrink the window by setting the left character to the leftmost character in the window. And if this leftmost character corresponds to one of the characters in T, and it also happens that before decrementing it, we just have enough characters for this T window over here, then we will decrement unique keys in windows, because it means that after you pop this character, the window is no longer valid. And we decrement the count in L char. And if the answer exists, then we will just do string slicing of answer left and answer right. Otherwise, we return an empty string if there are no valid sliding windows. Let's run this against some test cases. Wow, what mistake did I make this time? Let's see. ABC Adobe EC ADOBEC. Oh, interesting. ADOBEC. If window length is less than answer length. Oh, of course, I forgot to increment left by 1. So I think we also missed this previously when I was tracing this out. But thank goodness we noticed that. And that's pretty much it for this approach. So let's go through the time and space complexity over here. So time complexity and space complexity. So over here, if we let n to be length of s and m to be the length of t, then over here, we will have a time complexity of om to put all characters in T into the dictionary. All of this is O1. And the iteration of the right index from left to right is going to take on. And there is also a possible shift in the left index from left to right as we try to minimize the window. So this is really O2N over here. So checking whether if a character is in a dictionary, average time complexity is O1. We are assuming that the dictionary that we define is large enough so that there is no key collisions. In the worst case scenario, if there are collisions, then it will be OK, where K is the number of keys in the dictionary. In the worst case scenario, the dictionary will contain as many characters as in S, so K is equals to M. Yes, because window dictionary only contains characters that are in T, so K is equals to M. Worst case, this will be OM, but in normal cases, this will just be O1. So let's just take this to O1. So all of this stuff will be O1 as well, so that's fine. The time complexity of moving the left index from left to right is already here, so we can ignore that. All this stuff here that we do as we move the left index from left to right are pretty much O1. Similarly, checks in the dictionary is O1, average time complexity. And that's pretty much it. So in this case, the time complexity will be O2N plus M. And if you remove the coefficients, we get ON plus M, which corresponds with what the question is asking us to have. Let's go through the space complexity. So let's remove all of this stuff. We currently store like all characters in T into T dictionary, the counts for each character. So this OM in the worst case. If T contains only unique characters, then the number of keys inside T dictionary will correspond with the length of T, so giving us OM. And we also have window dictionary over here, but fortunately we have an optimization to only store characters in the window that is in T dictionary. So window dictionary will also have a space complexity of OM. So that's pretty much it. The rest of the variables, okay, I guess if you really want to count the output as using memory, then in this case this will be ON as well. In the worst case, if the window that is returned back has its characters in T spaced out in the whole string such that the answer is the same length as N, then the space complexity of this slice string is really ON. So in summary, the space complexity is ON plus 2M. And if you remove the coefficients, this gives us ON plus M as well. So that's pretty much it for this question. I personally didn't get this right the first time, and I uploaded a video where I tried to attempt this on the first try, and that didn't work out too well. I also didn't manage to figure out some of the optimizations that we just discussed over here. For example, this unique key in window and T unique keys in Windows to easily check whether if we have a valid window without actually doing a linear iteration across T dictionary. If you would like more information, you can watch our video, but I guess it is probably more helpful if you are curious how to recover under technical interview conditions. So that's pretty much it for this question. I hope that you enjoyed this. If you like this, please give us a like and subscribe, and we will see you in the next video.